Hello students, myself Dr. Swati. In this video, I will be explaining about Cannizzro and Crossed-Cannizzaro reactions. So this topic is one of the most important topic under Unit 4 Reactions of Carbonyl Compounds of Pharmaceutical Organic Chemistry 1, which is one of the core subject in B Pharmacy second semester. Now let us proceed with simple Cannizzaro reaction first. So what is the definition involved in it? So aldehydes containing no alpha hydrogen, they undergo self-oxidation and reduction in the presence of strong alkali to give mixture of alcohol and salt of carboxylic acids. So first let us see what type of compounds can undergo Cannizzaro reaction. So this reaction is meant for only aldehydes, and further aldehydes with no alpha hydrogen will only undergo Cannizzaro reaction. For example, formaldehyde. So let us look into the structure of formaldehyde. So formaldehyde is the first member of the homologous series which consists of only one carbon. So what is the meaning of alpha hydrogen? The hydrogen which is adjacent to the functional group or onto the alpha carbon. We can consider it as alpha hydrogen. So in this formaldehyde structure, there is no adjacent carbon atoms. That is carbon which is adjacent to the functional group. So this is the functional group, aldehyde functional group, and there is no carbon, that means alpha carbon, which is adjacent to the functional group. Hence there is no alpha hydrogen in formaldehyde. Same is with benzaldehyde also. So this CHO group is the functional group and there is alpha carbon here. The aromatic carbon is considered to be alpha carbon here because that is adjacent to the functional group, but this alpha carbon does not possess hydrogen. Remaining all carbons of benzene ring, they consist of hydrogens, but not at the first position. At first position, that hydrogen is already occupied with the formaldehyde group, that aldehyde group. So that is the reason there is no alpha hydrogen even in case of benzaldehyde. So such type of aldehydes containing no alpha hydrogen, they undergo oxidation and reduction. So upon oxidation of aldehydes, generally we will get carboxylic acid, salts of the carboxylic acids as the products, and upon reduction we get corresponding alcohols. So that is the reason upon Cannizzaro reaction of aldehydes containing no alpha hydrogen, we get a mixture of alcohol and salt of carboxylic acid. Now let us consider a few examples. The first reaction is between 2 moles of formaldehyde in the presence of 50% sodium hydroxide to give methanol and sodium formate as the product. So in this Cannizzaro reaction, the type of reactions involved are both oxidation and reduction. So you can see here formaldehyde upon oxidation in the presence of sodium hydroxide, we get sodium formate as the oxidative product, and another mole of formaldehyde upon reduction, we get corresponding alcohol, that is methanol, as the product. Now the second example is the reaction between 2 moles of benzaldehyde in the presence of sodium hydroxide to give benzyl alcohol and sodium benzoate as the products. So in this reaction also, 1 mole of benzaldehyde will be undergoing oxidation to give sodium benzoate as the product, and another mole of benzaldehyde will be reduced to benzyl alcohol. So these are the 2 examples for the simple Cannizzaro reaction. Let us look into the reaction mechanism. The reaction mechanism involves 3 steps. So in this, first 1 mole of aldehyde will be participating in the reaction, and on which nucleophile, that is sodium hydroxide or potassium hydroxide, will be using as the basic medium. So from that, nucleophile will be attacking on the carbonyl compound. And in the second step, there will be transfer of hydrate onto the second mole of the carbonyl, and which further upon protonation, we get the corresponding carboxylic salt of the carboxylic acid and alcohol as the product. Now let us look into this reaction mechanism by taking the reaction between 2 moles of benzaldehyde as example. So in the first step, whatever the base that we are using, either sodium hydroxide or potassium hydroxide, will be releasing the nucleophile, that is hydroxyl ion, and this hydroxyl ion will be attacking on the carbonyl carbon. As you are aware that carbonyl carbon is always electropositive because of the electromeric nature of the carbonyl functionality. So OH group will be acting as nucleophile and it will be attached to the electropositive carbonyl. So that is how you can see here OH group is attached to the central carbon of the aldehyde group, and once it attaches, the carbonyl carbon in the reactant will become pentavalent, which is unstable. So immediately the pi bond will be moved onto the oxygen, so that double bond O becomes O minus. So that is how we get this intermediate. Now this intermediate, you can see this is the intermediate. In the second step, it reacts with second mole of the benzaldehyde. Now in this intermediate, again the excess pair of electrons which are present on the oxygen will come in the form of double bond. So that CO minus will become C double bond O in the product. Now when the CO minus becomes C double bond O, immediately the central carbon atom becomes pentavalent. So that is the reason the pentavalent carbon is unstable. So this hydrogen along with the bonded pair of electrons will be transferred in the form of hydride. So this hydride will be transferred onto the second mole of the carbonyl carbon, because again carbonyl carbon in this also it is electropositive. So you can see that hydrogen is attached here in the product, and once that hydride comes onto the benzaldehyde carbon, carbonyl carbon, immediately that carbon becomes pentavalent. So that is the reason pi bond of the carbonyl group again moves onto the oxygen, so that it becomes O minus. So that is how we get these two products. So the next step involved is protonation. So what happens in this protonation? We have seen these are the products of the second step. Okay. So already here we get benzoic acid as the product, and the nature of acid that you know already, always the acid will undergo deprotonation. So these acidic protons will be shifted in the presence of sodium ions. Okay. So from where we will get these sodium ions? The base whatever we are taking in the initial step is sodium hydroxide. From that we have shown only the nucleophilic attack, that only OH minus attack we have shown. So in the medium we have sodium ions left over. So those sodium ions will be exchanged for the protons of the acid, so that we get sodium benzoate as the product. Now these protons which are liberated in the medium, they will be taken up by this benzyl oxy ion. So upon taking these protons, that O minus will become OH. So that is how we get benzyl alcohol as the product. So this is how benzyl alcohol, which is the reduced product of the benzaldehyde, and sodium benzoate, which is the oxidative product of the benzaldehyde, we get as the product upon Cannizzro reaction between 2 moles of benzaldehyde in the presence of strong base like sodium hydroxide or potassium hydroxide. So this is the reaction mechanism involved in simple Cannizzro reaction. So other example which I gave previously is the reaction between 2 moles of formaldehyde to give methanol and sodium formate as the products. So you can try the same reaction mechanism with this particular reaction also by pausing the video. Now let us move into the next topic, that is Crossed-Cannizzaro reaction. So what is this Crossed-Cannizzaro reaction, and what is the difference between Crossed-Cannizzaro and simple Cannizzaro reaction? If you see, in case of simple Cannizzaro reaction, the reaction occurs between 2 similar aldehydes, either 2 benzaldehydes or 2 formaldehydes. Whereas in case of crossed, the meaning of crossed is different. So here the Cannizzaro reaction occurs between 2 different aldehydes containing no alpha hydrogen. Again, the medium is same in the presence of strong alkali. The type of reaction is also same. These 2 different aldehydes will undergo self-oxidation and reduction, as a result of which we get mixture of alcohol and salt of carboxylic acid. Now let us take one example. So here we have to consider 2 different aldehydes. So one aldehyde, let us say it is formaldehyde, and another aldehyde is benzaldehyde. So these 2 undergo reaction in the presence of sodium hydroxide, and the products obtained will be benzyl alcohol and sodium formate. In previous simple Cannizzaro reaction, because 2 aldehydes whatever we take are same, the corresponding oxidative product and reduced product we can write easily. But in case of mixed aldehydes, that means 2 different aldehydes, which aldehyde will be undergoing oxidation and which one will be undergoing reduction is difficult to understand and make out. So the simplest thing is the aldehyde which is having less number of carbon atoms will be generally undergoing oxidation, and it gives corresponding salt of the carboxylic acid. So out of benzaldehyde and formaldehyde, the aldehyde with less number of carbon atoms is formaldehyde. So that is the reason this will undergo oxidation, and upon oxidation we get sodium formate as the oxidative product, and the other aldehyde, that is benzaldehyde, will be undergoing reduction, as a result of which we get benzyl alcohol as the product. Now let us consider the reaction mechanism for this Crossed-Cannizzaro reaction, which is the reaction mechanism is very similar to the simple Cannizzaro reaction. But here, whatever the aldehydes that we take in the first step will be forming finally the corresponding salt of the carboxylic acid. That means the aldehyde whatever we take in the first step will be undergoing oxidation. So in this mixed aldehydes reaction, because formaldehyde is the one which is having less number of carbons, so we have to consider formaldehyde in the first step. So first step is attack of nucleophile. Again the medium is same, either we take sodium hydroxide or potassium hydroxide. From this the hydroxyl ions will be acting as nucleophile onto the carbonyl carbon of the formaldehyde. So that OH group will be attached. As soon as the OH attacks on the carbonyl carbon, immediately pi bond will be moving onto the oxygen, so that double bond O becomes O minus. So we get a similar type of ion in the first step as that of the simple Cannizzaro reaction. Now in the second step, the formed ion in the first step reacts with another mole of the aldehyde. So the other aldehyde that we have in Crossed-Cannizzaro reaction is benzaldehyde. So from this again transfer of hydride occurs, and this hydride will attaches to the carbonyl carbon. And once the hydride along with the electron pair attach to the carbonyl carbon, immediately pi bond of electrons will be moving on to the oxygen. So double bond O becomes O minus. So as a result of which we get this benzyl oxy ion again with formic acid as the product in the second step. Okay, so after this what happens? Immediately once we get acid means in the third step protonation occurs. So before that the sodium ions which are released into the medium, they exchanged for the protons from the acid. So you can also consider it as a deprotonation reaction. So sodium ions will be reacting with the resulting formate ions, so that we get sodium formate as one of the product. While the protons which are liberated in the medium will be taken up by the benzyl oxy ion, and so that you can see here H plus will be attached to the O minus, so that we get corresponding benzyl alcohol as the product. So that is how upon Cannizzaro reaction, Crossed-Cannizzaro reaction between two different aldehydes, that is formaldehyde and benzaldehyde, we get sodium formate as well as benzyl alcohol as the product. So the reaction mechanism in Crossed-Cannizzaro reaction is also same as that of the simple Cannizzaro reaction. Now I hope you understood this topic and the basic difference between Cannizzaro reaction and Crossed-Cannizzaro reaction. So you can check your knowledge by doing these two questions also. So the first question here is, which of the following compound undergoes Cannizzaro reaction? Let us see the options. Option A is acetone. The next one is benzaldehyde, butyraldehyde and cinnamaldehyde. So before attempting this question, you can write the structure of these compounds and what is the prerequisite of any aldehyde to undergo Cannizzaro reaction. If you know that, immediately you can easily answer this question. Now I hope you answered the question. And the second question is, which of the following are the products of a Cannizzaro reaction between formaldehyde and benzaldehyde in the presence of potassium hydroxide? So I hope you understood that this question is related to the Crossed-Cannizzaro reaction. Now here are the four options: potassium formate and benzyl alcohol, potassium benzoate and methanol, potassium formate and methanol, potassium benzoate and benzyl alcohol. So in the Crossed-Cannizzaro reaction, the point which you have to remember is the aldehyde with lower number of carbon atoms will be undergoing oxidation and the other one will undergo reduction. So accordingly, you can easily make out the answer for this particular question. So I hope you got the answer for both these questions. So thanks for watching. And if you like this video and if you feel that this is useful for you, then please subscribe my channel so that you will get the notifications as soon as I upload some video. Thank you.